Okay, I believe it's doing what I want it to. So, all right, chapter 6, ether channel. So just want to restate this. The most important thing you can do for yourself here is practice. Practice this in Packet Tracer, and we're going to have the chance to do it with physical equipment. All right, so two things that we're going to tackle here with ether channel is bandwidth, so we can just increase our bandwidth with more cables. All right, and we're creating redundancy for that link. So that will show up as a single link. So physically, it's multiple cables, but logically, it's one link. Okay. All right, but STP doesn't like that, does it? As we just learned, that's going to create a problem. So if we can, put a blind eye, or at least make STP not see the two physical links and just see the one logical link, then STP will do its thing and we won't have to worry about it. So this is all called link aggregation. Link aggregation, ether channel. Yeah, it's just ether channel. There's two protocols that we can use to implement ether channel. Yeah, so all these benefits: fault tolerance, load sharing, increased bandwidth, and redundancy. So redundancy sounds like fault tolerance, but it's not. Okay. Fault tolerance is we did nothing, something broke or died, and it took care of itself. We didn't lose, we didn't have any downtime. Redundancy is a bit different. It's more than that. I'm forgetting the definition that I want to say to you. Basically, if we need to bring one down, it's not a fault. We have redundant systems, okay? So it has to do with, was it an accident or not? Okay, that's what we'll go with right now.
Where does STP fall in?
Everywhere, all the time. All the time. Again, STP is there unless you turn it off.
But I mean, it's both redundancy and fault tolerance, or is it?
STP only provides redundancy and fault tolerance.
So
yeah. Fault tolerance and load balancing often go hand in hand, or load sharing is another way to say that. Load balancing or load sharing, same thing. You're just splitting up the traffic 50-50, or whatever. There's a couple different ways you can split up the traffic. But yeah, and so that also increases your bandwidth hand in hand. When you load balance, that's going to increase your bandwidth. All right, makes it possible to combine all these physical links for switch-to-switch communication. So you think these are do you think these ether channels are also going to be trunks?
yeah.
Yes. Oh yeah. I will say this. You can do ether channel from a switch to a server. That's the other place where you do ether channel. It's beyond the scope of this course. I think they mention it. I think they mention connecting to servers. But yeah, okay. If your switch goes down, well, that's cool. It's got redundant links, that's whatever. But your server goes down, well, you have other servers, but just single NICs go down on servers. They die. Or the cable. One single cable is unplugged, cut, whatever. So anyways, that's another area that you can find it. All right, so this is an important thing to put in your brain. When an ether channel is configured, the resulting virtual interface is a port channel. Okay, this is a technology. This is the name of the virtual interface as you're going to see it on your switch. All right, so again, we just talked about the advantages. Most configuration tasks can be done in the virtual, so the port channel. Instead of on each individual port, ensuring configuration consistency. Yep. So yeah, you're gonna be using the range command, okay, right here. All right, there's no need to upgrade a link. So this is another reason Ether channel, if you know what to do, can save you money and provide load balancing fault tolerance, okay? You're just gonna lose the number of ports that you have available.
And that's port density, right?
Yep, that's why port density is important. Yeah. All right. Ether channel creates an aggregation that is seen as one logical link. When several Ether channel bundles exist between two switches, STP may block one of the bundles. Again, that's a logical switching loop at that point, so good. We need STP to block the logical switching loops. Okay? Usually you wouldn't do that. Usually you have different Ether channels on the same switch configured for separate switches. But yeah, you could take this and just double it. Sure. Don't ask me why you wouldn't just create one Ether channel versus two Ether channels. I cannot think of a reason, and I don't have time, and it's really late to think about that. Yeah, when there is only one Ether channel link, which is typical, all physical links in the Ether channel are active because STP sees only one logical link. Yep. So if you lose one physical link, it does not cause a recalculation. Just continues to work. You're gonna lose half your bandwidth if you have two links. So maybe do 3, 4, 5 cables so that the loss of one cable becomes less and less significant. You lose 20%, 33% of your traffic or bandwidth instead of 50. All right, restrictions. Types cannot be mixed. So fast Ethernet and gigabit cannot be done. Okay, they're not even saying you could just lower the speed. No. They're not saying that. So it needs to be the same type of port, same on both sides. Currently, each Ether channel consists up to 8 compatible Ethernet ports. So notice though, okay, if all we ever have is gigabit in our with our equipment, if we wanted to go faster, we still need to upgrade to 10 gig. Okay, still need to do that. Yeah,
So this is 8, is that 4 for each or 16 in all?
that's 8 gigabit
Oh,
bundle.
okay.
8 gigabit links in a bundle. All right, and then up to 6 Ethernet channels. So 8 each, 6. What's 8 times 6? 48. What's your standard? What's your, how many ports are up here, which occupy basically the entirety of the front of this device? It's 48 ports. Okay, but we usually have uplink ports. Okay, and those can be put in their own Ether channels, most likely. Is what you would want to do. So you can feed 8, or sorry, what does it say? 6. So you can feed up to 6 different bundles here through your combined up to 40 gigabit connection. Still not going to feed all of them, but stuff to think about. Got to size your pipes. All right. Ether channels can be formed through negotiation of one of 2 protocols. We have, all right, I'm going to call it PAG-P. That's how I say it in my brain. PAGP or LACP. With our brief detective work online, we're finding out that LACP is definitely the one that's more common, more sought after, but PAGP is not dead. There's enhanced versions of it. But we also do have the option to not use one of these negotiation protocols. All right. Oh, okay, so that's what they do say. PAGP is a Cisco proprietary protocol. So there you go. P proprietary. Cisco's. And then why do you think everyone online is telling you to learn LACP? Because it can be used with other vendors. Yes. And when are you going to be interfacing with other vendors the most? Stuff like VLANs, STP, and Ether channel, which combines all of that knowledge. Okay. So yeah, and yes, we're going to be doing it. Yeah, we're doing LACP. We're not doing PAGP. And they don't even talk about PAGP much, like what the differences are. They really. Oh, okay, yeah. When PAGP also manages the Ether channel, PAGP packets sent every 30 seconds. PAGP checks for configuration consistency and manages link additions and failures between two switches. It ensures that Ether channel is created. When an Ether channel is created, all ports have the same type of configuration. So that kind of implies that LACP is not going to be doing the same thing. Maybe, we'll see. Maybe we should try. Yeah, we could try this. These switches do have gigabit ports. I'm pretty sure these are all fast Ethernet. Yeah, they are. And then these ones are gigabit. So if you guys wanted to, when you go to do this tomorrow, you can connect, well, not these ones, those are SFP, but you could go from here to here, see what happens. Yeah, if you got the time. Okay. So this is another one of those situations like with DTP where you have the automatic configuration. You need to know what states will create a link with the other side. Okay. So this is kind of the, this is the static one on. It does not exchange these packets. So which one's going to be the most secure? Auto, desirable, or on? On. Yeah, because it's not sending out those packets. That's something you have to think about when you use negotiation protocols, are the automatic packets that are being sent out and how that can be hijacked. Okay. Yeah, many examples of different types of information that if you know enough about the protocol, you can figure out what might happen next and then hijack that. All right, desirable, active negotiation state, and then auto. Auto is a passive. You think it might be the other way around, but here we are. So auto is the passive and desirable is the active. So do you think these two are going to go together? Yeah, probably not. Auto and desirable, that will create a link. We'll come back to that. The modes must be compatible, and that's what the next slide is about. I'm just letting you read this. Just trying to figure out if there's anything I can add to it. Not really. It's just explaining what's going on right here. All right. So on, yep, yeah, that's gonna work. Manual. On does not work with anything else besides on. Okay. And then, so the only other thing to remember is auto is not working. Remember, auto is passive. Desirable is active. Why they didn't just use active and passive? LACP does. So do you agree with Reddit now? LACP better? So, yep, very similar. Because LACP is an IEEE open standard, anytime something is IEEE, it's open. Okay, it's open. Can be used to facilitate Ether channel in a multi-vendor environment, which is most of them nowadays. 20 years ago, yeah, you're probably only going to be working with Cisco in most places. It's not that case anymore. Okay, Cisco can't fend off and fight all the competition as these devices get cheaper. You know, Cisco also has the largest target on its back. Out of all layer 2 and 3 vendors, Cisco has the most vulnerabilities. Same reason Windows has the most vulnerabilities. It's what most people use. So that's what most people are trying to attack. And well, I mean, I don't know. Cisco is like Microsoft in the sense that they, they're an old monopoly. And it shows. If you want my honest opinion, it shows. All right. Okay. Yep, on, active, passive. All right, so active, yes. Passive, no. So this is pretty self-explanatory. On is only going to work with on. I would say this to yourself. Say it now, or say it when you're not so embarrassed. On. Active, passive. No passive. So I'm going to put this one in the Discord as well. I don't think you have I don't think there's going to be many PAGP questions on the exam. Okay, the following guidelines and restrictions are useful for configuring Ether channel. All Ethernet interfaces must support Ether channel with no requirement that interface must be physically contiguous. So what that means is you can use port 1, 5, 10, and 50. Well, not 50 doesn't exist, 48. You can just do all these random ports and combine that into an Ether channel. Is that easy to follow? No. It would be a lot easier to follow these banks of 8. So if you notice, Cisco likes to do banks of 8 or 6. Okay, 1, 2, 3, 4, 5, 6, 7, 8, and that's as many as you can do with Ether channel. Okay, so I could fully link this up 800 megabits each to 3 different switches, and then have this connect back most likely to like a core switch or something. It's usually why these 2 fast ports exist on the end there. And there's usually 2 of them for redundancy and load balancing, fault tolerant. Speed and duplex must match. VLANs must match. All interfaces in the Ether channel bundle must be assigned to the same VLAN or configured as a trunk. If they are configured as a trunk, they need to allow the same VLANs. So yes, this last sentence is important. If the allowed range of VLANs is not set the same on both sides, the interfaces do not form an Ether channel, no matter what. All right, so what do we got going on here? It's just telling you that the speed, duplex, and VLAN settings are the same on both sides. Okay, so what's important in here? If these settings must be changed, configure them in a port channel interface configuration mode. So in other words, go to don't go to interface fast Ethernet 1 and then 2, go to port channel 1, interface port channel 1. And then any configuration that is applied to the port channel interface also affects the individual interfaces. However, configurations that are applied to the individual interfaces do not go back up. So we can go top down, but we cannot go bottom up when it comes to affecting either the logical link or all the physical links. Okay, if you want to affect all the physical links, we affect the port channel, the virtual, logical. All right. Okay, so here is how you do it. Interface range, grab all your ports, and then you, let's see, yep. Channel group 1, mode, active. So in just one command, you set up the channel number, and you put it in a certain mode. And then we can go into the port channel and start doing the trunking stuff. And yeah, that's what you should do. Do the trunking afterwards. Sometimes you can't. In that case, if if FA01 was the existing trunk and I wanted to make it redundant, I would configure port 2 accordingly, plug it in. Well, maybe wait to plug it in because STP is just gonna recalculate and shut it off. Create the ether channel. And this is where especially these modes come into play. Okay, same thing with DTP. We learned that so that you as a single person could set up multiple switches one at a time. You don't have to bounce back and forth. Oh, which one has its thing screwed up? No, set it up correctly. You do auto or passive, whatever, and just move down the line. Okay. That way things come up and they come up quick. So yes, understanding these modes is especially important if you can't afford downtime and you don't have the privilege of having the whole network to yourself when no one's using it. A lot of these corporate networks, they're 24/7, 365, 5 nines. Everyone know what 5 nines means? 99.999%. That's an industry standard. It's like less than 5 minutes a year downtime. And that 5 minutes a year can be chalked up to issues and random errors in things that are unforeseen. All right, that's not planned downtime, that's unplanned downtime, right? So having extra equipment to shift the load to while you configure this one better and then move it back or combine the two, yeah, that's the science of project management. All right. Step 1, interface range, right? And then we can create it with this all one command. And then we can start changing things for the entire port channel. Trunk, loud VLAN. What are they missing here? What would a full trunking configuration include? 802 or no? Or DAT5. The native VLAN. Native VLAN. All right. So a lot of the same stuff, show interfaces just like you would any other interface, but now we have port channel. Show ether channel summary, show ether channel specific port channels. Show interfaces ether channel. So show interfaces ether channel, show interfaces Port channel, confusing, I know, but general status of the port channel interface versus about the role of a particular physical member. Excuse me. So this is more of a physical to virtual look, and then this is more of just a virtual look. All right. Common issues. All right. So they must have the same speed, duplex, and native and allowed VLANs, and access VLAN on access ports. Now, your ether channel is not usually an access port unless it's going to a switch. Just wait until you guys get into the world of virtual switches. All right. VLab uses them. I mean, yeah, it has to. We've got different VLANs for all the different classes. And that's all connected to a virtual switch. And then out of, clustering and all these other things. Anyways, it's all related. All right. Ensuring these configurations will significantly reduce network problems. Assigned ports in the ether channel are not a part of the same VLAN or not configured as trunks. Ports with different native VLANs cannot form an ether channel. Trunking was configured on some of the ports, but not all of them. So, okay, if you screw something up with ether channel, figure out what ports are supposed to be a part of it and clear them. Just start from scratch. You might have to pull up the running config in order to know what no commands to run. No this, no that, none of this, none of that. Get it blank, and then start from scratch, okay? When I did this for the first time, I screwed up, and I had to do that, and it was a little confusing, but use packet tracer, okay? All right. In the figure interfaces, yeah, okay. Troubleshooting. So what's going on? So they're both down. This is show ether channel summary. So we're getting the summary of the ether channel, but we get to see which ports are in here. Now notice it doesn't say protocol. So are we using LACP or PAGP? We don't know. It's not working. And what does this mean? SD. Suspended. Where's the default port? So suspended default port. Wow, we didn't learn about default ports. Don't worry about it. So here's the configuration for both of them. Spot the difference. Oh, I think I see it.
So there was no shut.
You would only see shut if it was shut. So they are no shutted. They are, yeah, that's a word. I mean, right now it's just spot the difference. I spy. Where's Waldo?
Oh.
All right, keep it to yourself. You four who are looking at the board,
Found it.
what's the difference? Oh, you're looking at the PowerPoint. There, that's smarter. So what do you think, James? What's the difference up here? Huh? Okay. All right. Same?
Mm-hmm.
Same?
Yeah.
Same?
Yeah.
Same?
Mm-hmm.
Same?
Mm-hmm.
Same?
Mm-hmm.
Same?
Mm-hmm.
No, it's not. And does on work with anything besides on? Nope. There's our problem. Congratulations, you have troubleshooted it. Troubleshot? I still haven't figured that one out. I'm pretty sure it's troubleshot, but that just sounds weird. But troubleshooted Does that sound weird?
Isn't it just troubleshoot?
I think so. Probably. No, but like past tense.
Right,
Troubles-
so you troubleshoot it.
Did you troubleshoot that last night? Yeah, I
Troubleshoot.
did troubleshoot that. Is it troubleshooted? Interesting.
When in doubt. Google.
Yep. But why do you think they're putting this into the PowerPoint? Troubleshooting. Have we had a troubleshooting slides here yet? No. So this is a common thing. There's many steps. All the pieces have to fit in order for this to work. So correct the misconfiguration. To correct the issue, the PAGP mode on the ether channel is changed to desirable. This is an easy fix, okay? If there was random stuff in here, like, VLAN 20 is gone. They didn't even set the native VLAN at all. Yeah. Yeah. Ether channel and STP interoperate. That's why we teach, that's why it's taught together. And then, yeah, because the order in which you do these commands is very relevant. Okay, which is why you see interface port channel 1 removed and then re-added with the channel group command, okay? So we're on S1. So we fix that, we put it into the correct mode. Nope. Notice how we're doing the range. Okay, so we need to grab our ports. And then once we have our range, we can do a channel group command. We shut it down. And then they go, okay, this is unnecessary. From here to here, and then they just repeat that command. Shut it down again. Okay, this. Okay. Okay, Cisco. Am I crazy? I think that's supposed to say S1 and S2. They just forgot to change the 1 to a 2. I'm pretty sure that's what's going on here. I mean, yeah, they do it here. S1, S2. So yeah, let's pretend that it says S2, 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 S2. Because yeah. Well, which side had the auto? That was S1 or mode, sorry, on. And then that was desirable. Desirable is the active state. So if we put it into desirable, active, yeah, that'll work. So that fixes S1. But this is just unnecessary. Okay, but then going back into so we go from range mode to port channel configuration interface. And then we make it a trunk. Yeah. That's most of the time what's gonna happen next. Yeah, so if you don't take down the whole port channel, what happens? STP freaks out and starts blocking things. And then now you've got STP problems. So at that point, nuke all of this, fix STP and start over. Or, copy run start in strategic times. You only get one save. right? You don't get multiple saves. Well, you do. How can we make that happen? Multiple saves. How do I save a certain state? A certain running configuration? How do I copy that out of the switch?
Start.
Nope, that saves it locally. How can I pull that configuration and put it in the cloud?
Not Flash.
Show run and copy it from the terminal emulator. Just don't accidentally paste that back in there because it'll paste the running config line by line back into the switch.
Hmm.
Who knows what that's gonna happen? Well, you just copied it, so you paste that back in there and copy run start and then reload the switch. But yeah, so you can also just capture text output from the terminal emulator. If you notice that, yeah, they both do it. You can save output to file. So save output to file, the first command you run is show run. There you go. There's that state. I will say Juniper switches, they have 10 states and they're called rollbacks. So you can roll back to a previous state before you, yeah, it's a little nicer, but all the commands are different. But the fundamentals do not change. What you guys are learning, the fundamentals, Cisco stuff aside, is awesome. All right, show ether channel summary. Now we see S, capital S, not lowercase s, and then we have capital U, not unsuitable, in use. Boom, boom. And then we have P. Bundled in port channel. Cool. That's it.